This presentation is a demonstration of the SLIM technology from Intercax. Specifically, we will be showing the first beta release of the SLIM plugin for IBM Rational Rhapsody, with interfaces to PTC Windchill, MySQL databases, and Siemens Teamcenter. Similar capabilities are available for MagicDraw. We'll begin the demo with a few introductory slides. Intercax focuses on helping organizations adopt best practices for model-based systems engineering, or MBSE. The core idea of MBSE is that the system can be represented as a single unified model, rather than a series of static independent documents. If such a model is shown as a network, the nodes are components like structural elements, requirements, and behaviors, while the links between them represent composition, flows, and dependencies. As a single source of truth about the system's engineering documents can be created from this model as a single source of truth. If some element of the model changes, the links can be used to propagate those changes and look at the impact of those changes. The model can be revised, and a new set of documents, consistent documents, can be created with a few keystrokes. SysML, the Systems Modeling Language, is a part of creating such a single system model, but it is only a part. If we think of that SysML model and all of its elements, each element is likely to be connected to another model in a different engineering tool. For example, a structural element might be connected to a CAD model. A behavior element might be connected to a simulation, and so forth for all of the other elements of the system. When we talk about the system model, we have to be talking about all of this information, not just the SysML model, which can act as a high-level roadmap of the system, as a clearinghouse for critical data at the system level, but all of those other data models. And so for this purpose, we have created SLIM, the System Lifecycle Management technology, which allows us to federate these models, the SysML model being at the center, but connected through the SLIM software layer to all of the other tools, where most of the engineering will still be done and where most of the detailed system data will still be stored. Now, there's several technical challenges involved in such a confederation of models. The first is simply connecting the tools, which is a particular problem if they're on different platforms, distributed over a network, where there are restrictions of access or firewalls. The second is more conceptual. The concepts in the different domains like systems engineering and mechanical design and simulation are different, so we have to make decisions about how we want to connect the concepts across the different domains. And the third challenge is that everything is constantly changing. We can think of this total system model as being only a snapshot along a timeline, and it changes. And as different product variants are created, either to maintain as new baselines or as simply for evaluation, we need to be able to manage all of the different versions of the total system model that are created. And for this purpose, we are focusing in SLIM on all of the challenges, but particularly on the challenge of change management and configuration and version control. And for that purpose, we're going to focus on the connections between SysML models and PLM systems, product lifecycle management systems, where these particular change control issues have always been addressed. Now, when we talk about federating different models across these connections, we have to do that in the context of what we are trying to accomplish with such connections. For example, two of the functionalities that we want to achieve in SLIM are connect and generate. Connect if elements exist in both domains already, for example in a SysML model and in a PLM part structure. And generate if they exist only on one side, and we want to create an equivalent structure on the other tool side. For example, if we have a SysML block structure and we want to create a PLM part structure from that, or vice versa, we would want to be able to generate such a separate structure, and a set of persistent connections between the elements on both sides that have been created. If we have such persistent connections, then there's several things we can do with them. We can check or compare the two models across that connection to see if changes have arisen over time. Second, we can update one model from the other. That is, we can push changes from one side to the other in either direction. The last functionality, execute, is not going to be shown in this demonstration. It involves the use of managing executable elements on the repository side and making use of them during larger executions from the SysML model. At this stage, let us go away from the slides and start the demonstration. We are going to present the demonstration within a particular scenario. The idea that we are functioning as a systems engineer for a systems integration house. We need to build a SysML model of a new unmanned aerial vehicle system. And we are going to do this using information from PLM repositories and databases to populate the SysML model. So we'll stop the slideshow at this point and we'll go to the IBM Rational Rhapsody interface. You can see that we have started off with a basic SysML model, a simple block representing the UAS, the Unmanned Aerial System, and one block that it owns of type payload. Now, the first task we need to do is to launch the SLIM dashboard. And for this purpose, we'll take the UAS system package, and then we'll, from that package, launch the SLIM dashboard. The SLIM dashboard is shown with several different tabs: the Repository Manager, Connection Browser, Connection Summary, Comparison Result, and Settings tabs. We'll go through many of these in the course of the demonstration, but we'll start off with the Repositories tab. SLIM allows us to create persistent connections to a variety of different repositories. And in this particular case, we'll use the Repository Manager to look at 6 repository connections that have already been created. We can add additional repositories as necessary. The first of the repositories is simply connections to my own local hard drive, my operating system. I can make connections to elements that I'm storing and managing within that hard drive. The second is to an element within a MySQL database. The third and fourth are to 2 different Teamcenter repositories, PLM systems, and the last 2 are to 2 different Windchill repositories, also PLM systems. For each repository, it's necessary to have a URL connection that allows us to reach that repository, and a set of user credentials, including passwords that give us access to portions of those repositories. In order to make a SLIM connection, I need to have that access. For that purpose, I would have to go to the PLM repository administrator and request this, because I will not have access through the SLIM technology to anything in these repositories that I would not have access to in other ways. In this way, SLIM retains the security provided by the PLM systems. In my particular case, the first task that I have to do with populating my SysML model is to go to a vendor's PLM repository, to which I have been given partial access, and to reach, in this case, a Windchill vendor repository through the SLIM dashboard, and to go to the product of interest, which in this case is the UAV SysML product, expand that, expand the folders, and specifically I want the aircraft platform folder. And within this folder, as we further expand it, we can see that there are multiple versions. 11 different versions have already been created of this. I'm going to take the latest version of the aircraft platform part structure, and if I go down there and look at it further, you can see that its additional parts are shown, and I'm going to drag that to the platform package, currently an empty package in the SysML model, and confirm that I want to generate a SysML block structure from the Windchill part structure in that part. As we look at the bottom, we can see a whole series of scrolling lines showing that not only the aircraft platform, but all of the parts and subparts within that are being transferred over and recreated on the SysML side. And when this is complete, we will see that not only the aircraft platform block, but all of the blocks representing its parts, subparts, and so forth are now on the SysML side. If we expand this further, we can see that the aircraft platform part structure has been carried over. If we go down, for example, to the body, take that further, and that its part structure is also captured. So we have captured a multi-level part structure in the SysML model transferred directly from the PLM system. If we go to the Connection Browser tab, and start to expand the platform package, we can see that not only have we created all of the individual elements over there, but we have also created a series of connections between those elements and their corresponding PLM components in the WC vendor. So we have persistent connections that have been created. The connection browser shows these in one fashion, and we can see that we have 27 different connections created. If we go to the connection summary and refresh the screen, we can see another way of looking at those same connections that have been created. On the SysML tool side, if we now go and look at the UAS system and expand the packages that have been created and go to the platform package, you can see that all of those blocks now appear within the IBM Rational Rhapsody tool. And if we take the aircraft platform and drag it into the BDD, we now have the ability to create a part relationship between the UAS and the aircraft platform, so that we've added not only this part of the part structure, but all of the underneath parts as well. Now it's time to populate the payload side of our system. For that purpose, we'll go back to the SLIM dashboard, but we will go on the Connection Manager tab to a different repository. In our scenario, we will assume that my organization has created a database containing potential payload components and maintains this on a regular basis. So I will go to that database, which is a MySQL database, and open it up and go to a table in there called Component, which contains the information that we maintain about the different payload components that are potentially available. Not only the name of the component, but columns including other values like cost and mass. So I'm going to select a particular series of components that I want on the payload for this particular system. I'll choose a payload controller, a wide-angle IR detector, a data bus, a radio modem, a communications controller, just as an example. And what we will do now is drag these over into the payload package on the SysML side. And we will recreate them in the SysML model as specializations of a general block called component. So we'll say yes, we'll go through the process, and when it's complete, you can see that we've created a series of blocks within the payload system. Not only the component block, but the 5 specializations of that component block that represent elements for our payload. If we go back to the SysML screen again, we can now take those elements that have been created in the payload package and drag them into our BDD. And you can see that not only have we created the elements that we want, we have carried over the values from the MySQL database table as default values for mass and cost within those specialized blocks. And once again, we can use the directed composition relationship to build the part structure now from the payload block to the various components that make it up. So again, with a few keystrokes, we have taken information from outside repositories and used it to create a fairly complex SysML model. That completes the first part of the demonstration. The second part will look at what happens as things change. To continue with our scenario, let us assume that while we are creating this SysML model, other engineers within my organization are consistently maintaining the database about payload components, updating it where new information becomes available from vendors or other sources. So let's go back and temporarily take the role of a second engineer who is updating the MySQL database. So here I'm working directly with the database through the MySQL workbench. And I've taken the testdemo.component table, and I look at it here, and I'm going to make some changes. We, for example, discovered that the communications controller is now $50, and the payload controller mass in the latest version has gone up to 2.5 kilograms. So we'll take those changes and apply those changes to the database. So they have now been put into the database, but we have not yet had a chance to update the SysML model. And we will use Slim now to look at that part of the process. The first part of the process is to ask, have changes occurred since we created these blocks initially? And for that, we're going to go to the connection browser, and we're going to go and look at the payload connections, and we're going to ask, as we look across all of these different connections, has there been changes created? So we'll go to the payload package and ask it to compare the SysML and target. And when we do that, we generate a table in the comparison result tab that shows differences that have arisen. And these are the two that we just looked at. The mass of the payload controller has gone up. It was 1.5 initially when the SysML block was created, but now it's 2.5. Similarly, the cost of the communications controller has changed as well, from $25 to $50. Now, if we choose, we can sync the values in the MySQL database to their corresponding default value properties in the SysML model. And once again, we go back to the connection browser and choose how to do that. We're going to do that in this case across individual connections, though we could do it across all at once. For example, across the payload, the communications controller, we will click on that, and we will tell it to sync the target to the SysML. In this case, the value in the MySQL database will be synced to the SysML model. And we'll do the same with the payload controller. Sync target to SysML. And now, having updated the SysML model, we should be able to go back to the IBM Rational Rhapsody dashboard and look at those particular values. And we can see that indeed the cost of the communications controller has now been updated to 50, and the mass of the payload controller has now been updated to 2.5 kilograms. Now, those changes in the payload components may require changes in other parts of the system. For example, let's take a look at the engine. We'll drag that in here as well, and we can see that there is an engine that is part of the aircraft platform. And let's consider the possibility that we decide we need a second engine to handle the greater mass of the payload controllers. So I'm going to go to the directed composition and create a second part of type engine within the model. And now we've changed the SysML model. We have to ask, how does that impact the original aircraft platform model on the PLM system at the vendors? So once again, we can go to the SysML dashboard. We can go to the platform package, and we can ask it to compare the SysML and target model across the connections within the platform package. And in this case, we have quite a few connections that we need to check across that. But as we do that, we will see that we generate a table there. And as we scroll down through that table, we'll see that there's indeed a change. There is a new engine part in the SysML model that has no corresponding part within the PLM repository. Now, at this case, the question of how to deal with this mismatch is an open question. It may be necessary to call the vendor, request a change, but it's also possible to make those changes directly through the SLIM interface. Now, while that may not be the desirable work process, the technology allows that. We can go back to the connection browser. Specifically, we'll go to the aircraft platform connection, and we will update the PLM model from the SysML model in this case. Notice that the aircraft platform version is currently A11, the one that we originally linked from. When we sync a SysML model to the target, however, we are going to need to update the PLM version because we're changing the aircraft platform. And when we do that, we can see that it is indeed now version A12 that has been created. But the mismatch has been eliminated by the SLIM technology. So we have shown that we can compare the SysML model with the elements in the outside repositories. We can also update in either direction from SysML to target or from target to SysML. We have just a few other additional capabilities that we'd like to demonstrate in this. One is the possibility of taking other elements besides part structures and bringing them into the SysML model. For example, some organizations manage their requirements within a PLM system. For example, here in the TC user repository, Teamcenter repository, we will take a look at the contents of that through the SLIM interface, and we will see as we expand it that it has a section marked requirements. And as we go down through that and expand that, we can see the individual requirements that are being managed in Teamcenter. It may be that we want to be able to import some or all of those requirements, individual requirements or entire specification structures, from the outside repository into SysML. We can do that in the same way of dragging and dropping. We'll take the speed requirement and drag it into the UAS system package on the SysML side. We can see that it's now been created over there. If we go back to the SysML side and go to the requirements package that's been created, you can see that we can now drag that in to the system. At this point, we can create a satisfy relationship from the engine block to the speed requirement. And we can now begin to create connections between requirements and structural elements, both of which were originally managed in outside repositories. The last task that we might want to be able to do is to take the entire new part structure that we've created in the SysML model and put it into our own PLM system. In this case, for example, a Teamcenter system within our own organization. We'll go back to the connection manager. We'll go to a different Teamcenter repository, one where, for example, I may have write privileges, and where I've created an empty package called UAV demo. And what I'm going to do now is to take the UAS block, the top level block that I've created in Rhapsody, and drag that into the UAV demo folder and generate a Teamcenter part structure from the SysML model that I've built. This presumably will be populated with CAD files, analysis results, and all of the other documents that are going to be part of the system development process. And so as we go through this process, we can see that a whole variety of different elements are being created, and we now have an aircraft platform and a UAS block with its own part structure created. Version A1, we can view its part structure. It has a payload block and a platform block, and so forth as we can drill down. We've now created that on the PLM side. That completes the demonstration part of the presentation. To go back to the final slides, demonstrated how as a systems engineer we can use SLIM to populate a SysML model and then use it to seed a PLM structure. For those of you who would like to try on an evaluation basis the beta release of SLIM, it's very simple. Simply go to our website at www.intercax.com/slim and follow the instructions. We'll provide the evaluation license at your request. In addition to the software, there's a detailed user guide with installation instructions and also a series of hands-on tutorials to help guide you through the initial steps in the different processes that we've shown here. We particularly value your feedback on the capabilities of SLIM that are being developed. We have many opportunities to add additional interfaces, different SysML modeling tools, different repositories, databases. One area where we're working right now is in making interfaces from SysML elements to CAD files, so that, for example, design parameters may be imported from CAD into the SysML model to evaluate their impact at the system level. Now, new capabilities are being driven very specifically by customer demands. That completes our presentation. We'd be happy to answer any emails that you would like to have if you have further questions, either to Dr. Manas Bajaj, our Chief Systems Officer, or to me, Dirk Swamer. Thanks very much for your attention.